Okay, hello class. So this is our first lecture for the first lab quiz. So our first lab quiz is based on Earth's geographic grid. So I'm going to be going over all the concepts and some example questions from your lab. So to begin, the geographic coordinate system, it is a coordinate system that enables every location on Earth to be specified by a set of numbers or letters. Earth's grid system uses lines of latitude and longitude. So this is an example of a globe, and if you've seen globes, you can see that there's a lot of lines extending from north to south, and then east to west. So these lines are known as latitude and longitude. Specifically, specifically the arrow pointing at this line, this is a line of latitude. And this arrow pointing at this line, this is a line of longitude. And you can think of these lines as a graph. So like a graphing paper with like an XY coordinate system. So for example, we have a dot here, we have Washington, D.C., and from the x-axis, we're reading the latitude, which is 39 degrees north latitude, and then from the y-axis, we're reading it as 77 degrees west longitude for Washington, D.C. So we're going to go more in depth into latitude and longitude, but this is an overall example of Earth's grid system. So for parallels of latitude, so the lines, circles of the grid that extend in an east to west direction. So these are the lines that extend to an east-west direction. But basically, they are measured in degrees. So as you can see here, 30 degrees, 60 degrees, 90 degrees, but also the distance, they are designated the distance of either being north or south of the equator. So all lines of latitude except the equator are labeled north, which would, if it's north of the equator, it's 30 degrees north, 60 degrees north, 90 degrees north, or they are labeled south of the equator, so 30 degrees south, 60 degrees south, and 90 degrees south. So that is very important to know that these are the two directions on how they will go, north or south. And the maximum degrees for latitude is 90 degrees. So that's the maximum degree, is at 90 degrees at the North Pole and 90 degrees at the South Pole. I put this diagram specifically so it could help you to answer the special lines of latitude. So these are the special lines of latitude. The Arctic Circle at 66.5 degrees north, and the Tropic of Cancer, which is this dashed line, at 23.5 degrees north. And then again, we have the equator, and the equator is 0 degrees. It's not designated north or south, but everything above is north and everything below is south. We have Tropic of Capricorn, 23.5 degrees south. Again, it's represented by this dashed line, and the Antarctic Circle at 66.5 degrees south, represented by this dashed line as well. And all these latitudes are circles, so they extend around the Earth and they are parallel to each other, but with the exception that the North Pole and the South Pole, these are considered points. So they are not circles, but they are points. And from the right side of the diagram, this is just telling you the general location of these latitudes. So generally between 30 degrees north to 30 degrees south, we have the low latitudes. and the mid-latitudes are between 30 degrees north to 60 degrees north. Again, applies the same way. It applies the same way to the southern hemisphere, 30 degrees south to 60 degrees south, and then the high latitudes, 60 degrees to 90 degrees in both hemispheres. And then again, the maximum is 90 degrees. So moving on to meridians of longitude, these are lines, half circles that extend from the North Pole to the South Pole. So they extend, the lines extend from a north to south direction, but their direction, the distance is measured in degrees, as you can see, but they are designated a different format. So everything from the right side of the prime meridian, it is designated east. So 10 degrees east, 20 degrees east, so on and so on. And then everything to the left side of the prime meridian, it is designated as west. So all lines of meridians are designated west to the left of the prime meridian, and all lines of the meridian are designated east from the right side of the prime meridian. So the opposite value, so the maximum value of the longitude is 180 degrees. So that's going to be the opposite of this line on the other side of the world, and that is known as the international date line. So again, this extends 0 degrees all the way to 180 degrees, and then again 0 degrees to the eastern hemisphere all the way to 180 degrees. So all lines of meridians are designated east or west, except for the prime meridian, which is 0 degrees only, and 180 degrees at the international date line. So every other line of the meridians are designated west or east. And yeah, so again, this is a diagram from the lab, and it's showing you latitude in this picture. So again, 0 degrees to 90 degrees north and 0 degrees to 90 degrees south. And longitude, so this is a picture of the longitude. So as like what I was explaining earlier, the prime meridian is at 0 degrees, and then right on the opposite side of it is 180 degrees, and that's the maximum value from the western perspective and the eastern perspective. Okay, so this diagram is in your quiz, and it could be a little bit confusing based on the latitude and the arrows. So what this arrow is really showing you is that it's showing you what the latitude line is, and it's pointing at the latitude line, which is this latitude line. So that's all the arrows pointing towards the latitude line. It's pointing at this latitude line, which would be 15 degrees north latitude, because it is north of the equator, because there's 0 degrees. So, and again, this longitude arrow is pointing at the longitude line, which is running north to south. And this would be 60 degrees east, because it is to the right of the prime meridian. And yeah, so that's, and also the Earth's grid system, it's measured in degrees, and what it's showing you is it's like they are putting a protractor in the center of the Earth, and measuring out with the protractor how many degrees is the Earth from the center. So like 15 degrees with the protractor, 30 degrees, and then 90 degrees with the protractor. And again, that's how they do it with the longitude. So that's one way to think of it when you see the degrees and angles. So another concept that you'll be learning is the great circle and the small circle. So a great circle is a plane that is passed through the center of a sphere and bisects that sphere. So when the sphere is divided into equal halves, it is known hemispheres. So the examples of great circles would be the equator, because it cuts the Earth exactly in the center, and all lines of longitude. So when you combine the prime meridian with the international date line, that is a great circle, and circle of illumination and plane of the ecliptic. Also, we have the small circle. So a small circle does not divide the globe into two equal halves. So all lines of latitude except the equator are small circles. The next concept in your lab is based on the length of a degree. So we have a chart here, and it tells you the length of the degree at the equator. So the statute miles is 69.171. So if we're going, let's say, up north to 30 degrees north, so farther up on the Earth's grid, it is 59.956. And then when we get close to the North Pole at 60 degrees, the miles drops considerably to 34.674. And then when we get to the North Pole, the length is 0.000. So one way to look at this concept is to look at it that every degree, the length of a degree, is 69 miles at the equator. So every length of this degree is 69 miles. And when we get to 30 degrees, the length between here, it got shorter. So from what I remember, it's 54 miles. And then when we go higher in latitude at 60 degrees, it drops considerably. So the length between these longitudes, it is, I think, 34. And then the North Pole, as you can see, it's 0.000. So the length of the latitude line in between, it shortens and it drops to the value of 0 at the North Pole. So that is what you guys will be working with in this lab. So, oopsie. So this is an example question. How can the distance around the world along 60 degrees south be calculated, and what is that approximate distance in miles? So you would look at 60 degrees and you would find the statute miles, which is 34.674. And to solve this, you would multiply it by 360 degrees. And I got that answer, that value, from the prime meridian on the Western Hemisphere, 0 to 180 degrees, and then on the Eastern Hemisphere, 0 to 180 degrees, 180 plus 180 equals 360 degrees. So you would multiply 34.674 with 360 degrees, and that would be your value. So This is an example question, so solve the problem the same way as you would in the quiz. So another example question is, how many miles are between the following two locations? 30 degrees south, 60 degrees west, and 30 degrees south, 90 degrees east. So they're giving us the latitude, and we know that this is latitude because it's designated south, and we know latitude is only designated north or south of the equator, and we know that this is longitude, 60 degrees west, because it's designated west, and this is longitude as well because it's designated east, and we know that longitudes are designated only west or east of the prime meridian. So for our first step, it says sum the total distance between the points in degrees. So we're gonna sum only the longitude coordinates. So I have an example here. We're gonna add 60 plus 90, which gives us 150. So next, we're going to multiply that sum by the statute miles for that line of latitude. So we know we're at the same line of latitude, which is 30 degrees south. So we're going to go to 30 degrees, and that's the statute miles. We are going to multiply that with 150, and you get your value of 8,993.4. So this is how you would answer the question in your lab. So moving forward, we are now going to talk about degrees, minutes, and seconds. So there are two formats for subdividing a degree. There is decimal degrees and degrees, minutes, and seconds. So the DMS format, also known as DMS, so it would be 60 degrees, 30 minutes, and 45 seconds north. So this is breaking it down to be really exact on the location of Earth. Instead of just saying like it's 60 degrees, we're going to be more exact. So this is how we do that with these two different formats. And then we have the decimal format, which is 60.5125 north. So you will learn how to convert the DMS format to the decimal format. So here's a quick rule. Each degree can be divided into 60 equal parts called a minute. Each minute can also be divided into 60 equal parts called seconds, which can be noted as 1 degree equals 60 minutes equals 3,600 seconds. So to review, there are 60 minutes in 1 degree and there are 60 seconds in 1 minute. So just like with time, minutes and seconds cannot exceed 60. So it's talking about this section right here. So the minutes, it cannot go past 60, and the seconds cannot go past 60 as well. But the 60 degrees, the degrees can only go up to the maximum of the latitude degrees, which we know is 90 degrees, and then the longitude degrees, the maximum is 180 degrees. So it just depends on where you are, on what latitude or longitude you're talking about. So moving forward, we are going to be converting DMS to decimal degrees. So to convert, you only need to convert minutes and seconds. So the example from the lab manual is we have 60 degrees, 30 minutes, and 45 seconds. So for minutes, we are going to divide by the minutes. So 30 divided by 60 equals 0.5. And for the seconds, we are going to divide 3,600 with this value. So 45 divided by 3,600 equals 0.0125. And next, we are going to add 0.5 plus 0.0125, which will give us the answer of 0.5125. And we are going to keep 60 the same, and we're just going to put the 0.5125 right after it. And that will be your final answer. So that's how you will solve that problem in your quiz. And this, you guys will be working with the geographic grid as well. And it would be this exact grid. So I just put little pointers here. So this black line represents the equator, and this black line represents the prime meridian. So we know that prime meridian is at a value of 0 degrees and the equator is at 0 degrees. And the increments would be 30 degrees for the latitude and longitude. So this line would be 30 degrees north, this line would be 30 degrees south, 60 degrees north, and then again the same for the longitude lines, which we know extend in this direction. This is 30 degrees east, 60 degrees east, and again here 30 degrees west, 60 degrees west. So I gave an example of what is the value of, what are the coordinates of this circle. So I'm first gonna find out the latitude and then the longitude. So the latitude is found on the equator. So that is 0 degrees. And I didn't put north or south because we know that 0 degrees is by itself. Next, we have that it's found on this line of the meridian. So that's 30 degrees, and it's east because it's to the right of the prime meridian. So 30 degrees east. So you guys will be working with finding the coordinates for A and B. So this is an example question from your lab, and it's what is the latitude and longitude of Furnace Creek Ranch in Death Valley. So you guys will be using this link, and with this link you'll be searching in the search bar Furnace Creek Ranch, and it will tell you the coordinates in degrees, minutes, and seconds, as well as decimal degree format. So the next concept is based on the Earth's time zone. So time on Earth can be observed in two different ways, either using the sun or utilizing standard time. So solar time uses the noon-sun angles to calculate the apparent solar time. So this is an example of the sundial that uses solar time. And this is an example of the standard time. So this is what we use currently. But for the purpose of this lab, we will be using solar time. So an important variable related to solar time is the noon meridian, which meridian is another word for longitude. Which is the meridian that is experiencing the subsolar point where the sun is at its highest point in the sky. So as you can see here, the subsolar point is hitting the Earth at a 90-degree angle, and this is when the sun's rays are mostly concentrated, and this is the time where it's 12 noon. This is when the sun's rays are the highest. And yeah, so the latitude that has the sun's rays directly overhead is the subsolar point. So the subsolar point looks like it's hitting the equator in this example, but the farthest the subsolar point will go is between the Tropic of Cancer and the Tropic of Capricorn. So moving forward, we know that the Earth rotates 360 degrees in 24 hours and has a revolution around the Sun every 365 days. Another way to observe this is that the Earth will rotate counterclockwise 15 degrees every hour. So the rule is 1 hour equals 15 degrees, 1 degree equals 4 minutes. So we will be using these rules to solve our time problems. So again, this is a time zone chart, and the starting point is at Greenwich, England, so it's nearby London, and it's starting at 0, and anything to the right of Greenwich, England, it is ahead, so the time is ahead, and it's eastward. So, and anything to the left of Greenwich, England in this zone, it is behind in time, so it's earlier in time, and it's westward. So for example, we see Sweden here, and it says a +1, so it's 1 hour ahead of England. And in the bottom it tells you the time, so the time is sun, so the noon time, so it's 12 p.m., so it's 1 hour ahead of 12 p.m., so this would mean that Sweden is at 1 p.m. And if we give an example with New York, it is, let's count, so it's 1, 2, 3, 4, 5, and then it's really small, but it has subtraction of 5 here, and it is 5 hours behind Greenwich, England. So this would mean, if this is at 12 noon, New York would be 7 a.m. And again, the sun is basically moving westward. So they experience, so they're always later than us because we live in California. So now we are going to solve time problems. So this is one example question. So assuming that you lived along 50 degrees east longitude and it was solar noon, what would be the solar time at 80 degrees west? So I highly recommend for you guys to do a chart like this, like on a scratch sheet of paper. So this represents the longitude lines. So 0 degrees is the prime meridian, and then extending to the left is 180 degrees west, and extending to the right, it is 180 degrees east. And we know from earlier that 180 degrees is not designated east or west, but for the purpose of this lab, it is really helpful to designate it in this case. So first what we're going to do is plot the location, and I already plotted the lines, but basically I put 50 degrees east longitude here, and I put 80 degrees west longitude here. And it's saying that it's solar noon, which means that it is 12 p.m., the subsolar point, at 50 degrees east longitude. So we are trying to figure out what is our solar time here. What is the solar time? So to find that out, we are going to calculate the distance in degrees. So from 0 to 80, it's 80, and 0 to 50, it's 50. So to calculate the distance between that, we are going to add 80 plus 50, which equals 130 degrees. Next, we are going to convert degrees into minutes. So to do that, we're going to take our value 130 degrees, and I'm going to multiply it by 4 minutes. And I'm doing that according to this rule, 1 degree equals 4 minutes. So that will convert our degrees into minutes. So our value is 520 minutes. Next, we're going to convert minutes into hours. And so the 520 minutes, I simply used a unit converter from minutes into hours, but so you could also use that if you want. And from that, I got 8 hours and 39 minutes. So there's an 8 hour and 39 minute difference between these two locations. Since we're trying to figure out the time of this location, we know that it is to the westward side of the prime meridian, so we know the time is earlier. So it's 8 hours and 39 minutes earlier than 12 p.m. So the answer is 3:21 a.m. So that is the solar time at this longitude. And I did a little quick rule here. So if it's the same hemisphere, subtract. So in your quiz, if you have a location of 50 degrees east longitude and 80 degrees east longitude, you would subtract to calculate the distance when you solve for step 2. So for our next question, this one is different. The other one, we were trying to find the solar time. This question, we are trying to find longitude. So assuming that it is solar noon at your location, what is your longitude if the time at the prime meridian is 7 p.m.? So again, I'm using this diagram, and I highly recommend you guys to use this for your word problems. So plot the known location. So the known location they gave us is the prime meridian. So I first put my little stick at the prime meridian at 0 degrees. And that is 7 p.m. here. So we know the known location. And now we have to decide if my location is earlier or later in time. So for us, we are 12 p.m. So 12 p.m. is earlier than 7 p.m. here at prime meridian. So we are to the left of the prime meridian because we know that to the left of the prime meridian it is earlier. So I just put my little stick here and I'm just guessing like, okay, well, I'm earlier, so let's just put it here because we are west of the prime meridian because we are at 12 noon. So next, how many hours separate these locations? So if I'm 12 p.m. and they are 7 hours ahead of us, the difference between us is 7 hours. So we're going to convert our hours into degrees. So we have our 7 hours here, and I'm multiplying it by 15 degrees because with this rule that we have, 1 hour equals 15 degrees. So this will tell us our location. So 7 hours times 15 degrees equals 105 degrees. So I put the west direction because we are on the left side of the prime meridian. So we are west. So 105 degrees west. So that is how you will solve your question in your quiz.